Hello everyone. So in this problem, we have to find the values of a and b. Now a represents the coefficient of this sin x term and b is this term by itself on the right side of the equation. Now in order to find the value of a and b, we'll have to reduce this expression on the left side into an expression with just sin x. So that means we have to get rid of this double angle here, the cos of 2x, and we'll have to get rid of the terms in the denominator because we only want this sine of x in the expression. So here we'll have to modify this expression. So we can start with the numerator. Now as we can see in the numerator, in the parentheses, they have two terms, 2 minus 2 cos of 2x. So the first step here is to factor out or do common factoring. In the parentheses, we can factor out a 2 and we are left with 1 minus cos of 2x and close the parentheses. Over in the denominator we have a sine square x and then minus 2 sine x plus cos square x. Now here we can use the Pythagorean identity. So as per the Pythagorean identity, so I'll write it on the side. So sine square x plus cos square x is equal to 1. So that means if we add these two terms, we should get 1. So the denominator becomes 1 minus 2 sine x. Because minus 2 sine x stays as it is, we just combine the sine square x and cos square x. So we add them. Now we can simplify the numerator. So we have to convert this double angle into a x. So we have to use the double angle identity for cos. Now as you may know, double angle identity for cos comes in three forms. Now we need to use the form which has just sine in it because we only want sine in the simplified expression. So that is cos of 2x is equal to 1 minus 2 sine square x. Now we have to rearrange the terms in order to isolate 1 minus cos 2x. So we can do that first by adding 2 sine square x on both sides. So that way we can move sine square x to the left side of the equation. So this 2 sine square x on the right side cancel each other out. So we get cos of 2x plus 2 sine square x equals 1. And now we can subtract cos 2x from both sides. So the cos terms on the left side cancel each other out and we are left with 2 sine square x equals 1 minus cos 2x. So this is the rearranged form of the cosine double angle identity with just sine in it. So this is the substitution now we'll do here. So we'll replace 1 minus cos 2x with 2 sine square x. So we get 1 minus 2 and the parentheses 2 sine square x. Over. Now the denominator has already been simplified. We cannot do anything else in the denominator. Now we can simplify the numerator by multiplying the 2 by this 2. So we get 1 minus 4 sine square x over 1 minus 2 sine x. Now we can simplify the numerator by using difference of squares. So I'll show the formula for difference of squares on the board. So a square minus b square. So this is a kind of factoring we do. A plus b times a minus b. Now in the numerator, so I'll show you the steps here on the side. So 1 can be written as 1 square minus, now 4 is a perfect square, so 4 can be written as 2 square sine square x over 1 minus 2 sine x. Now we can combine the 2 square and sine square x into a single parenthesis. So we can write 2 sine x and we'll put a parenthesis around both of them and put a square outside. So this changes the numerator expression into a difference of squares expression. Now we can apply the difference of squares formula. So we get 1 plus 2 sine x times 1 minus 2 sine x over 1 minus 2 sine x. Now we can cancel out these 1 minus 2 sine x's. So we are just left with 1 plus 2 sine, which can be rearranged by writing 2 sine x first because that's the expression on the right side of the given expression. So this is the reduced form of the left side of the equation. Now we have to find the values of a and b. So a here is the coefficient of sine x. In this case, the coefficient of sine x is 2. So that means the value of a is 2. And b is the number being added to the sine x term. And in this case, b is 1. So this should be the final answer for this problem. So these are the steps you have to keep in mind to solve this type of problem. I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.